Hey folks, Harsha here from the team at eGMAT. In this video, we are going to discuss a super interesting 700 level OG question. Now, if you have already solved the question, fantastic. Else, this is your chance. Pause the video, solve the question, and then come back to this. Alright? So, what is it that's so great about this question? So, it is a 700 level OG question, and this is a question that we had floated on the YouTube channel a couple of days ago, and here are the responses. Only 24% of students have chosen the right answer. That's option A. Options B and E are extremely popular incorrect option choices. We're going to discuss those in detail. Now, what makes this question very, very interesting and unique? It is the logic that's at play here. So, this particular question employs an analogy. It uses an analogy as part of its logic. What do I mean by that? You guys have read the question, so you can understand what I'm saying here. First, the author talks about some aspects, let's say X, Y, and Z, about bats. Then the author introduces another species called Sandactylus. Then the author tells us that hey, Z was discovered in Sandactylus. And here's where it gets interesting. The author believes that the mechanism that is at play with bats with regard to XYZ, the same similar mechanism should be applying to Sandactylus as well. And based on this aspect of a very analogous thing happening with Sandactylus as what's happening with bats, based on that, the author makes the conclusion that hey, the discovery of Z is proof that the same X which happens with which is an aspect of bats must also have been an aspect of Sandactylus. So here the use of the analogy of bats is an interesting aspect. Another aspect is what the exact conclusion is. The conclusion is not that X is an aspect of Sandactylus or was an aspect of Sandactylus. The conclusion is that Z, the discovery of Z, is proof that X was an aspect of Sandactylus. So the way the conclusion is written, you have to be very careful and understand it properly, else you could face some difficulty when you go to the option choices. Now, this is one aspect that's very tricky in this question. The other aspect is the option choices. Options A, B, and E are all difficult options. The problem with options B and E is they do not satisfy the must be true condition. Now, if you attended the CR session that we conducted a couple of days ago, then you know what we mean by must be true. Any assumption must satisfy this particular characteristic called must be true. What does it mean? For a conclusion to hold true, the assumption statement definitely has to hold true. In other words, if your assumption statement is not going to hold true, then your conclusion should shatter. So how do we use this practically in an assumption question? Through the negation test. Any option choice that seems tricky, you should employ the negation test. Now, for example, option E. If you negate option E, if your conclusion is breaking down, then it would be a valid assumption. If you see that your conclusion does not necessarily break down, you can easily find scenarios where your conclusion does not break down, then it's not a valid assumption. That's what's happening with options B and E here. We're going to look into that as well. So with that, let's get into the crux of this argument, understand this argument perfectly. Okay, so let me just bring in the sentences. Yeah. The first sentence says networks of blood vessels in bats' wings serve only to disperse heat generated in flight. So the word only is again very important. It kind of makes it very, very specific as to what's happening here. So firstly, let me just go back here. Firstly, we are talking about bats. So what do we know about bats? Bats have these networks of blood vessels. Let's call that B. They serve only one purpose. They exist for one purpose only. That one purpose is to dissipate the heat that is generated in flight. Heat generated in flight means the heat that is generated when a bat is flying. Okay, that's the first sentence. Now let's go to the next sentence. This heat is generated only because bats flap their wings. So now we are told that this heat that is getting generated, which has to be dispersed here, this heat gets generated because of only one reason. That reason is that the bats flap their wings when they are flying. So let's call this as W. So W is for flapping of wings, H is for heat that is generated or dispersed, and B is for blood vessel network. So essentially, from these two sentences, what do we know? Bats, essentially, what happens with bats? Bats use their wings to fly, they flap their wings to fly. This leads to generation of heat. In order to dissipate this heat, bats have something called blood vessel networks. The only purpose of blood vessel network is to dissipate heat. The only way heat gets generated is by wing flapping. This is the overall summary of those first two sentences. Now let's move on. Thus, so the author is making some kind of a conclusion. That's a conclusion marker. paleontologists. Paleontologists are scientists who study fossils, but that doesn't matter. Thus, paleontologists' recent discovery that the winged dinosaur Sandactylus had similar networks of blood vessels in the skin of its wings provides evidence for something. Let's hold on to that. Let's first break it down. So therefore, paleontologists discovered something, and their discovery is not related to bats. Their discovery is related to some species called Sandactylus. Now Sandactylus is some kind of a dinosaur with wings. So what is so great? What have they discovered? These paleontologists discovered that this species called Sandactylus, it also had similar blood vessel networks in the skin of its wings, or in other words, similar to how bats had blood vessel networks, this species also has blood vessel networks. That is the discovery. Now the author says this discovery, it provides evidence for something. What is it? Let's move on. It provides evidence for the hypothesis that Sandactylus flew by flapping its wings, not just by gliding. Or in other words, the author claims that the discovery of this blood vessel network in Sandactylus, it is proof that the Sandactylus flew by flapping its wings, not just by gliding. Or in other words, gliding is okay, the Sandactylus also glides, but definitely it also flew by flapping its wings. This is the core conclusion. It is the only claim in this entire argument. It's therefore the conclusion. Now, if this is clear, let's go to the question. The argument in the passage relies on which of the following assumptions? So it's a clear-cut assumption question. Okay. Now, let's specifically crystallize the conclusion and logic in our minds before jumping into pre-thinking. Okay. So, the conclusion is very clear. The conclusion is that, hey, this particular discovery of blood vessel networks, so we are talking about Sandactylus, this discovery of blood vessel network in Sandactylus, it is evidence which shows that the Sandactylus flew by flapping its wings also, not just by gliding. So, this is the core conclusion. Notice, the conclusion is not that Sandactylus flew by flapping its wings. The conclusion is that this particular discovery is proof that Sandactylus flew by flapping its wings. There is a difference, you should notice that. Alright, so now let's understand the logic at play here, because this is where it gets very interesting. So essentially the logic here is simply some kind of an analogy. The author has observed something with bats, and one of those aspects that was observed with bats was discovered in Sandactylus, and therefore the author assumes that the very same mechanism must apply here, and that's the basis for the conclusion that's being made. So let's understand that. So what do we know? In bats, fundamentally bats flap their wings for the purpose of flight. This flapping of wings leads to heat generation. To dissipate this heat, and only for that purpose, you have blood vessel networks. This is what has been observed in bats. The core logic is that the author believes the same thing must apply to Sandactylus also. In Sandactylus, the author has already observed that blood vessel network exists. It has been discovered. The author believes that the same thing must be happening with Sandactylus. That is, these blood vessel networks must probably be used for the same purpose, that is heat dissipation. This heat must be being generated by the same means, that is flapping of wings for the purpose of flight, and therefore Sandactylus also must be flapping its wings should have been flapping its wings for the purpose of flight. So this is the core logic. The author assumes that what happens with bats, the same mechanism is applicable to Sandactylus. Therefore, once the fact that this was discovered, blood vessel networks was discovered, it is proof that Sandactylus also flew by flapping its wings. This is the core logic at play here. So I hope this is clear. Now, with this as clarity, let's move to the next step, that is pre-thinking. Again, first frame the falsification question. The conclusion is that the discovery is proof that Sandactylus flew by flapping its wings. So what do we need to know? In what scenario is this discovery not proof that Sandactylus flew by flapping its wings? Okay, so that's what we need to find, given the mechanism that's observed in bats. So if you think about it, what are those conditions that can actually break this conclusion? So to understand this, you have to understand the analogous logic that applies to bats. So what do we know with bats? Bats, they flap their wings. This flapping of wings is essentially what generates heat. It's the one source that generates heat. This heat that's generated, it gets dissipated by blood vessel networks whose sole purpose is to dissipate this heat. This is what is happening in bats. Now, if you want to break this chain, If you want to prove that this is not what is happening with Sandactylus, all you have to do is actually break the chain. So number one, the author's core assumption seems to be, the author seems to be assuming that just like in bats, even in Sandactylus, these blood vessel networks must be having the purpose of heat dissipation. But in reality, what if it is not so? What if in reality blood vessel networks have no purposes that are related to heat generation? So one situation, blood vessel network has some other use, some other singular purpose which has nothing to do with heat generation. So it's the purpose for the existence of blood vessel network is not for heat generation, it's for some other purpose. If that's the situation, if that is the case, then the author cannot still say that the discovery of blood vessel network is proof that wings, the Sandactylus used to flap its wings for the purpose of flight, because this chain gets broken, because blood vessel networks were used for some other purpose which has nothing to do with heat generation. Okay, that's one condition that I can think of. Another condition I can think of is, what if this particular blood vessel network has no use at all? Again, it is again attacking this linkage that's right here. The author is assuming that just like in bats, blood vessel networks must be for the purpose of heat dissipation. So one scenario we saw is, what if it's for some other purpose entirely? Another scenario is, what if this is a vestigial organ which has absolutely no use? Even in such a case, the very same logic applies. Then if you are the author, this discovery of blood vessel network cannot be used as a basis to claim that Sandactylus also used to flap its wings for flight. Why? Because this does not serve the purpose of heat generation. In reality, it does not serve any purpose at all. This chain is yet again broken. So that's another falsification condition we can think of. A third way of breaking the conclusion, another falsification condition we can think of, this attacks this part of the chain. The author again seems to be assuming that just like in bats, flapping of wings would lead to heat generation. But what if that's not true for Sandactylus? We do not know what Sandactylus is made of in terms of material, maybe in terms of the actual material of the skin. Maybe the way Sandactylus is, the flapping of the wings does not even lead to heat generation. That could be true. If that is true, yet again this chain is broken. So irrespective of what purpose the Sandactylus, the blood vessel network serves, maybe it is for the purpose of heat generation or heat dissipation, we don't care. But even if it is for the purpose of heat dissipation, this chain is still broken. Why? Because flapping of wings in Sandactylus does not lead to heat generation. Then just because you have blood vessel network, again you cannot claim that the Sandactylus used to flap its wings for the purpose of flight. Again this chain gets broken. So this is another falsification condition, and therefore we have arrived at 3 falsification conditions. What I want you to observe is how, by thinking logically, if you can visualize it, you can actually arrive at multiple very, very logical situations. Now, what are the underlying assumptions here? Let me move this away. You get those by negating your falsification conditions. So assumption 1 is these blood vessel networks in Sandactylus, they do not serve some other completely different and singular purpose. That's not true. They exist for heat generation. That's one situation. Another situation is these blood vessel networks, another assumption is these blood vessel networks that you observed in Sandactylus, they do not exist without any purpose. They have to have some use at the very least. Why does it work? Because if you negate it, that means that blood vessel networks are existing in Sandactylus without any purpose. Then again, you cannot assume that it is doing any kind of heat dissipation. You cannot assume that. The chain gets broken, and again your conclusion breaks down. The third assumption is related to the other linkage, that is, flapping of wings should be leading to heat generation in Sandactylus just the way it's leading to heat generation in bats. If flapping of wings is not at all leading to heat generation, yet again this conclusion breaks down. So that's a third assumption that you have for this particular question. If this is clear, now we can move to answer choice analysis. So first let's look at option A, which is the correct answer, which only 24% of us have actually been able to get. But now with this pre-thinking that we have done, it should be very clear. Sandactylus would not have had networks of blood vessels in the skin of its wings if these networks were of no use to Sandactylus. So it's a very complicated way of saying that these blood vessel networks had some use. So it's actually in line with our assumption 2 here, which says that it definitely these networks had some use in Sandactylus. You cannot say that they had no use. It's just a very convoluted way of saying the same sentiment. Why does it work? Again, it's because of this logic that is being used by the author. Remember, the author's logic is the logic of which is being used, the mechanism that's being used for bats, applying exactly the same way to Sandactylus. In other words, in bats, the wings get flapped. This leads to heat generation. To dissipate this heat, you have blood vessels, and the purpose of this blood vessels therefore is to dissipate heat. Now, in reality, if these blood vessels, now coming to Sandactylus, if in Sandactylus these blood vessels have no purpose whatsoever, they do not really perform the function of heat dissipation, then this chain gets broken. Then just because blood vessels have been observed in Sandactylus, we cannot conclude that, or we cannot claim that Sandactylus used to flap their wings. Therefore, option A, if you negate it, it will break the conclusion. So option A is the only correct answer. It is in line with our pre-thinking. Now let's move to option B. This is where things get very interesting. It's one of those option choices that a lot of you have chosen. So option B says all creatures that fly by flapping their wings have networks of blood vessels in the skin of their wings. But again, does it matter that all creatures who flap their wings have blood vessels? No. As long as Sandactylus has blood vessels and Sandactylus has blood vessels for the purpose of flapping its wings, for the purpose of heat dissipation, it's perfect. So whether all creatures have these kinds of mechanisms, we don't care. So that's the easiest way to reject it, but let's also apply the negation test and be very, very clear about it. So firstly, let's again summarize what the argument tells us. As per the argument, if you look at bats definitely they flap their wings for the purpose of flight, and we also know that they have blood vessel networks. With regard to Sandactylus, we know that they have blood vessel networks. The conclusion is about whether we can definitely say that they also use their wings for they also flap their wings for flight. Now option B, if you negate, what does it tell us? Or not all creatures that fly by flapping their wings have network of blood vessels. Or in other words, there may be some creature that is P or Q. There may be some other creatures or animals that are P or Q which fly by flapping their wings, so W is there, but these guys do not have blood vessel networks. The question you have to ask is, so what? Does this have anything to do with Sandactyl, which you already know has blood vessel network? As far as Sandactylus is concerned, this particular creature already has blood vessel network. Option B is only telling you that there will be some creatures P and Q that will not have blood vessel networks. So what? Sandactylus already has blood vessel network. We are only concerned with whether this blood vessel network is evidence that can be considered as evidence that Sandactylus also used its wings by flapping for the purpose of flight. This does not tell you anything about that. In other words, even in this situation, there might be these other creatures which do not have blood vessel networks. So what? In the case of Sandactylus, these blood vessel networks, we already know they exist, and for all we know, they exist only for the purpose of dissipating the heat that is generated by the flapping of wings. In other words, even in your negated option B, your conclusion can hold true, which makes option B an incorrect option choice. So it's a very well crafted option choice. You have to be very slow and methodical with it. Okay, so I hope this is clear. Now let's go to option C and D. These are the easy to eliminate options. Option C says winged dinosaurs that flap their wings in flight would have been able to fly more effectively than winged dinosaurs that could only glide. Effectiveness of flight is out of scope. We do not care. The conclusion is not about which kind of flight is more effective, whether it is flapping of wings or whether it is gliding. As far as Sandactylus is concerned, we don't care. Effectiveness of flight is not what your conclusion is about. Therefore, option C is very easy to reject. Alright, so option D is slightly trickier compared to option C, but again it's a very, very easy option, honestly. So what does option D say? If Sandactylus flew by flapping its wings, then paleontologists would certainly be able to find some evidence that it did so. Or in other words, if it is true that Sandactylus flew by flapping its wings, that is, if even in the case of Sandactylus it's definitely true that they used to flap their wings for the purpose of flight, then at some point of time paleontologists will find some evidence for it. Whether it is this blood vessel networks or whether it is some other X or Y or Z, we don't know, but at some kind of evidence will be found at some point of time. The minute you read this, it should be a red flag, because this particular conclusion is about whether this one discovery that has been made, that is blood vessel network in Sandactylus, whether this one particular thing is evidence. Just what does option D have to do with that? Option D just says that at some point some evidence will be found. It has nothing to do with whether this particular piece of evidence that has been found, with this particular discovery that has been made, is that countable as evidence for this particular hypothesis. In reality, it has nothing to do with that. So it should be an easy reject, but you could still apply the negation test. I'll show you how. If you negate option D, it would mean that if Sandactylus indeed flew by flapping its wings, then paleontologists may not necessarily be able to find the evidence. So it's debatable whether they'll be able to find the evidence. So you're not 100% sure, because the original statement says they will certainly be able to. If you negate it, you'll say not certainly. So maybe they'll be able to find, and maybe they will not be able to find. So if there is this possibility that they will be able to find some evidence, what if that evidence is this blood vessel network? So you found the blood vessel network, and this discovery is perfect evidence that Sandactylus used to flap their wings for the purpose of flight. In other words, even if you negate your option D, your conclusion can hold true. But honestly, for option D, you should not even be going towards negation. You should be rejecting it straight. So option D is also not the right answer. It's actually irrelevant, right? As far as this argument is concerned, whether or not paleontologists will be able to do it, not relevant. We already have something which is being evaluated, whether this particular discovery is evidence. Okay, think about that. Now let's go to option E. Heat generated by Sandactylus by flapping its wings in flight could have been dispersed by anything other than blood vessels in its wings. So this is the option choice that around 54% of students have chosen. It's the most popular option choice, but let me explain why it's wrong. What does it say? Heat generated by Sandactylus. So you're talking about Sandactylus. Okay, let me just put this here. You're talking about Sandactylus, the heat generated by Sandactylus in flapping its wings in flight. So thanks to the flapping of wings, there is this heat that's being generated. This heat could not have been dispersed by anything other than blood vessels in its wings. Or in other words, this heat is being dissipated only by blood vessel networks, and it's not possible that there is some other X or Y, that is all X or Y, which could also be means of dissipating that heat. This is what option E is trying to say. Why is this wrong? You have to negate it. So what if this heat dissipation can happen through other sources as well? Think about it. Let us say there you have X, B and Y. These are three primary mechanisms of heat dissipation. B is of course the blood vessel network, and then you have these other two, X and Y. Option E, if you negate, it means that the heat that is generated by the Sandactylus, that is this, it can be dispersed, it could have been dispersed by other factors also, by other aspects also, like X or Y. So let us say that 30%, if the heat generated is 100 units which has to be dissipated, let's say 30 units gets dissipated by X, 30 units gets dissipated by B, and 40 units gets dissipated by Y. Now, even if this is the situation, it can very well be possible that B exists only for the purpose of dissipating these 30 units of heat. In other words, as long as, even if there are other means of heat dissipation, provided the blood vessel networks exist only for the purpose of dissipation of heat, which is very much possible, the conclusion will still hold true. So the only reason why these blood vessel networks exist is for dissipating these 30 units of heat, and in that case, that means that the existence of this blood vessel network is at some level proof that wing flapping is happening, because this heat, even these 30 units of heat, it's being generated by the flapping of the wings. In other words, even if you negate option choice E, your conclusion can still hold true. So just because there are other sources does not matter. As long as blood vessel networks is used for that purpose, the purpose of blood vessel networks, as long as it is heat dissipation, does not matter. Your conclusion can still hold true. So that is the reason why option E is incorrect. I hope this video was helpful. There are quite a few learnings here. Firstly, use the negation test for any option that you cannot straight away reject. So A, B and E are all tricky options. You should have done this. Again, be very careful in understanding the core logic. You have to understand the mechanism that's at play with regard to bats, and you have to see how the author is using a very analogous logic for Sandactylus as well, and understand what the conclusion actually is. The conclusion is about whether that particular discovery is proof, and it's not about whether Sandactylus actually has used wing flapping or not. Okay, and again, notice how if you do a very logical pre-thinking, you can easily arrive at these kinds of conditions and scenarios. Alright, so I hope this video is very useful for you. Happy learning.